Now that we know a bit about the properties of groups, it's reasonable to ask questions like the following. Let's let G be a group, and I'm going to let A and B be any elements in G. And my question is this: are there solutions to the equations? And the first one is going to be A, and I'm going to stress that the X here is a variable by putting it in a different color. So AX is equal to B, and likewise we can turn the product around here and write it as X times A is equal to B. Now it's important to realize that if G is a non-commutative group, then the expression AX and XA may not be exactly the same for some values of x. So we don't want to think about these two equations as being the same equation. They are two separate equations. So in a non-commutative group, this is not necessarily true. And so these are two separate equations. So I want to think about how I would go about solving these equations. And I'm going to think about working on the first equation, and I'm going to leave this particular one for you in a quickly jot. So let's think about solving AX is equal to B. So again, remember that our x is a variable. We're trying to solve for the x. And we are in a group. So I want to solve this in a group. And that's important because if I'm in a group, one of the things that I know is that I know that since A is inside the group, there exists an A inverse inside the group. And I know from our four important lemmas that A inverse times A is equal to A times A inverse. It doesn't matter which order we do. They're both going to be equal to E. This part was our axiom. This part was one of our lemmas. So what I'm going to do is I'm going to pre-multiply this equation by A inverse. And we've seen this trick before. So we're going to look at A inverse times A times X is equal to A inverse times B. Now I do want to stress something that's very important. Because we do not have commutativity as a given, we do have to multiply both sides of the equation on the same side by A. We have to either pre-multiply or post-multiply, and in this particular example, pre-multiplying is what we want to do. Of course, once we have that, then things become easy. This is now A inverse A times X, and the other side, of course, is equal to A inverse B, whatever that is. But now we're looking at E times X is equal to the element A inverse B, and of course E times X is just X, so we wind up getting that X equals A inverse B is a solution to the equation A times X is equal to B. Now, once we have one particular solution, there is an obvious question to ask. Can there be more than one solution? And in order to investigate that, we're going to basically do a standard technique from the way we prove things in mathematics. Let's assume that both S1 and S2 inside G satisfy the equation A times X is equal to B. And then what I know what that means is that I have A times S1 is equal to B, and I also have A times S2 is equal to B. But these two things together are going to tell me that A times S1 is equal to A times S2. And now we can pull the same trick that we pulled before. Let's pre-multiply by A inverse. And when we do that, this is what we get. But we can reassociate because we are in a group. And once we've reassociated, we see that this element here and this element here are both E by the definition of A inverse and our lemmas. So this now becomes E times S1 is equal to E times S2. But we now do know that identity elements work on both sides by one of our lemmas, and so this does say S1 is equal to S2. Well, what this means is that we have only got one solution. So that's an important thing to be thinking about. This basically says there is there's only one solution to A times X is equal to B inside the group G. What we have done is we have proven a proposition, and I want to state that proposition carefully and correctly. So we have proved this proposition. Let G be a group. And my Wacom tablet is having some trouble keeping up, so let me clean up my notation. Let's let A and B be inside G. Then the equation, and that is messy handwriting. The equation A times X is equal to B has a unique solution in G. It is important to realize that the proof that, so let me actually write this down as a statement. The proof that the equation X times A is equal to B has a unique solution is very similar. And our author leaves it as an exercise for the students, and you will be doing that in a Quickly Jot assignment.